Welcome to the React Show, brought to you from occupied Miwok territory. I'm your host, Thomas, and today we also have my co-host, Richard. I'm super excited to have you here, Richard, because I've had this burning question on my mind lately. Okay, that's not the whole truth, is it? You're the one that brought this up, isn't it? What is it that we're going to talk about today, Richard?
Well, thanks, Thomas. I guess I was thinking in the past, probably 10 years ago, something like that. I saw Lambda as a possible service on AWS. And I'm like, what is this?
Yeah.
So I guess I had some excitement around that.
So you want to find out if you should use serverless? Is that what you're getting at?
Yeah, exactly.
Yeah.
Keep it simple.
I mean, it's like, what is serverless? You know, like we're gonna have to figure that out. But first, before we talk about serverless and Lambda and all the fancy new things like, you know, edge functions and Vercel and all that, right? That's the goal. I think we're gonna get into that. But first, the truth is, I'm pretty tired. I didn't sleep as much last night. Did you know about this?
Yeah, I didn't know about that.
Yeah. What? Yeah. So I was out partying, bike party, East Bay bike party. So, you know, I don't know. Richard didn't join. Why didn't you join me?
Sounds like a good idea, but you know, next time.
Next time?
Yeah.
Really?
Yeah.
Really?
Well, maybe not that far. Didn't you go real far?
I was only like 15 miles. That far?
That's far.
That's far. It usually goes past a few BART stations, so you can like only go part of the way.
Yeah, I guess it's not that far if there weren't that many hills.
Yeah. No, it was pretty flat. There was like a hill to start, but then it was pretty flat.
Yeah, maybe.
Yeah.
I'd consider it.
So what's this coffee we got here today?
You know what? It's Say brand from New York, from Brooklyn.
Oh, that sounds like what do you call it? Highfalutin?
Highfalutin. I think it is highfalutin. That's the definition of it.
Is it good though?
It's really good.
Is the shot
quite
good?
A few.
Did we try this one yet?
We did try this one, and I think this is the second time around.
But I tweaked it.
What'd you do?
I tweaked the grind a bit from the last shot. I made it a little bit more fine, so it should be. I'm thinking a little more extracted.
Let's try it.
Yeah. All right. You go first.
I don't know what to say about that.
We're just gonna sit here. There's not gonna be. You're just gonna hear some slurping and yeah. Does it taste better than the last shot?
It had a little more fruity flavor to it this time, I think.
I think so too. Is it over extract? Is it like kind of bitter or astringent, or is it just pretty good?
That probably is obnoxious to do that, right? But
yeah, it's all right. I can maybe mute that out of the audio track. I was hitting the mute button when I was.
Were you?
For me, but I don't know when you're gonna do it. So
you leave me on there. Okay.
I just leave you on. Yeah, I mean your slurps, they just sound so much better.
Right. No, I think it's really good. That's a good coffee. I don't have the. We should probably put the one that is on the bag on your.
Oh yeah. We can put in the notes for the podcast.
Yeah, exactly.
Yeah. I really like it. It's very fruity. I would say if you like the really fruity stuff.
Yeah. I think it's really high quality, definitely.
Yeah, and you were saying before, it just seems really smooth and
well balanced.
Yeah,
that would be my take.
Which is perfect because that's how. You know, I would describe serverless, right? Like it's got the acidity, it's got the fruit, well balanced. I mean, it's basically everything I ever wanted, you know, when it comes to deploying services and stuff.
Yeah, I mean, I think so. I think I thought about some of the positives around that, and I think I'd like you to refute them. I mean, if I'd like to go down.
Well, are you hyped? Are you like into serverless?
Yeah,
Are
so.
you're thinking you might be?
I'm thinking I might be.
Have you done it before?
A little bit, yeah.
Okay.
I have.
What'd you do?
I fooled around a little bit with AWS, and you know, like I said, I didn't know if I wanted to go this direction. But when I first saw AWS, a Lambda, I thought it was sort of a fragment of code, a method perhaps that you would put on Lambda, and then it would be sort of an endpoint for you to access that method, as
Oh,
opposed to
okay.
serverless, where it was sort of provisioning my whole server, my
Yeah.
whole system.
So like you were sort of psyched about your idea of what it meant.
Exactly.
And now you're like, maybe that's not really what it means or something?
I mean, I think it's a subset of what it means.
Yeah.
What I initially
So
thought.
what did specifically, what did you initially think? Like if we took an actual project, you know, what would it actually mean to deploy it using the mental model you originally had?
Yeah, the mental model I originally had was sort of a discrete or sort of self-contained method that I could put on Lambda as sort of a service.
Uh-huh.
And the reason I thought that was a good thing was it was self-contained, easily
Yeah.
tested. It's sort of mentally, it's like that service is there. This is what it does.
Yeah.
So that concept of sort of separating that from a sort of a more complex system had some that would seemed attractive to possibly
So
do that.
so like if you needed to add one to a number, you could create
Exactly.
a add one serverless function and call that whenever you needed to add one to a number.
Exactly. Exactly. That's what I thought it initially was, and I sort of tucked that away in my mind as something that,
Yeah.
hey, this could be something from my larger system as a service to that larger system.
Yeah.
But subsequently talking about it, I mean, there's other features around that I think that are larger than just that.
Yeah, yeah. So you're initially thinking you're pretty excited because you're like, "Hey, that actually sounds really cool," because like I guess you were maybe I imagine you were thinking, "Oh, I don't need to spin up the servers to add one. Like
Exactly.
I could hit this add one function with 10,000 computers at the same time and it would just magically handle the load."
Yeah, it would scale. It would handle security. It would be well defined, easily tested.
Yeah, yeah.
So potentially a lot of benefits,
Yeah.
at least on a first look.
Yeah, yeah, that makes sense. Um, so I guess like maybe we could talk a little bit more about the specifics. So I think what you're talking about and sort of imagining
Hmm.
to me reminds me a bit more of what is kind of the new hype, which is the edge functions.
Exactly.
And not exactly the way that AWS Lambda I think is originally designed. So my understanding of AWS Lambda and similar things like Google Cloud and Azure, however you say that, they all have this type of thing, right?
Right.
Serverless. Basically, the idea is some bit of code that just runs, and you don't have to manage its deployment. I think that's the big thing, right? So serverless
Exactly.
is all about I don't need to set up a Linux machine. I don't need to know how to configure it. I don't need to know how to turn on the firewall. I don't need to know how to deploy code to it. I don't need to know how to update it. I don't, all these things. It just handles it for you, right?
Yeah, and I guess essentially I wasn't wrong at my first look. It was there's more to it than that, and I could still get that if that's what I wanted. Um, but I think I'm still a fan of it and of the serverless, and we could talk more about that. But it didn't really end anything for me in terms of my mental model, but it just had to change. So
Yeah, yeah. So I think yeah. So my understanding is the sort of mental model around the actual serverless functions is more you're taking like say a route handler. I think
hmm
the way people often might see this is like in Next.js or Remix or other like if we're talking about React, other React frameworks, um, will take each of your API route functions and run them in this AWS Lambda type infrastructure. And so that means it's potentially pulling in any libraries that you've installed on your system for this server. It's not purely just running just the dependencies of that specific function. Now, that being said, I think they are working on tools to, and maybe some of this already exists, so tools to like figure out the specific dependencies for that specific route and only installing like the node modules that it needs. So it's kind of bringing it closer in line with what you were thinking.
Catching up with my ideas, I guess.
Yeah, but of course, I think edge functions are more what you're talking about. And at this point, I just want to more clearly define it for anybody that's not familiar. So at least the mental model I have for a serverless Lambda type function. This is the default when you're using NextJS and deploying it to like Vercel for the API routes. Is basically it's a virtualized Linux server running Node.js, and this you could do this for other platforms like Ruby on Rails or whatever.
Right.
But it actually spins up a Node.js server, loads in, npm installs all your dependencies, then loads the code for that route, takes the request, passes it to that route, runs it, and returns a response.
Right.
So that's sort of the traditional serverless. Then we also have edge functions, which are somewhat newer. Edge functions are generally a lot more restricted. So you can't just run anything. So like a lot of node modules, they call like local or not local, like native, like C or Rust libraries. So you might have like for image resizing, you have the sharp npm package, but internally that calls C code.
Right.
So using a regular like Lambda function, that works fine because it's basically a virtualized Linux environment that's running it. Edge functions are generally specific to a runtime. So like for a JavaScript-based edge function, it's just running your code on top of the V8 Chrome engine that Node.js normally runs on, but you don't have access to the rest of the Linux system. And generally, for edge functions, all of your dependencies have to be compiled in. There's no npm install. It's all baked in. And they generally have like a 1 megabyte limit or something for the entire code. So basically, it's a lot more like what you originally thought. Basically, it's a bundle of code that automatically gets deployed and runs somewhere when you call it. And there's no like external to JavaScript dependencies to whatever.
I don't know if we want to talk about that. I kind of do. That doesn't make entire sense to me because if we're talking about the issue of cold start, if my server and my code gets provisioned and I hit that endpoint, say on Vercel or whatever else, and it serves up what I'm doing, third-party things are being used inside my code, and it gets returned. The second hit is not going to be a cold.
Yeah.
Right? Is that correct?
For a regular serverless function,
right.
Yeah.
So now why, if I use Edge, why can't I do the same? All it's really essentially doing is hitting it once and preparing it for me. Why is there this limitation of third party?
Yeah. So first, what is a cold start? We haven't talked about that.
Well, my understanding of cold start is, it's provisioned your server and nothing's been loaded into memory. Nothing's it's just sitting there waiting to be hit. Those endpoints are waiting to be hit.
Yeah.
Once you hit it the first time, it's built up some of these things into memory, and then the second hit is going to be faster because of that.
Yeah, so cold start would be like your code is not loaded into memory on a server.
Right.
And maybe other things too, like there's not the networking set up to route requests to it or whatever.
Right. It's a cold start.
Yeah. So the way it would work is like your front end makes a request to the back end, which is this serverless function. And say that's on AWS. AWS is going to get that request. And the first time it gets it, it's going to be like, oh, this is a serverless function. I'm going to spin up the serverless function, load it into memory, and then process the request, like send it to the serverless function. The first time you do that, it's got to take a little bit of time. It's basically got to load up that entire environment, essentially install your dependencies and all this stuff. And so there can be a bit of a delay.
Mm-hmm.
But then after that, it could leave that running, that instance running, and any new requests your front end sends to the back end, it reroutes or routes it to that existing instance. Or maybe you get a whole bunch of traffic and it needs to spin up multiple instances. Anytime it spins up an instance, it's got to reboot, reload everything into memory. You're going to have a cold start.
Mm-hmm.
But after that, it can route to any of these instances that are running, and it won't have to reload it into memory, so it can process your request much faster.
Right. And the whole for me on that one, and that whole discussion is why the limitation on those third party. If it's loaded, if it's my server that's been provisioned and it's loaded into memory, however it needs to be loaded, I don't understand why there would be a limitation.
Why there's a cold start at all?
No, I understand the cold start part, but you said if I want to have the edge, right, edge function, why can't I have, why are there limitations on this edge function? There shouldn't be any limitations, I don't think.
So the difference is, I believe that the architecture for edge functions is they're not necessarily spinning up a Linux environment for every function. They're basically giving you a slice of a instance of node running on V8. And that instance is the same for everyone.
Gotcha.
So I think that's the big difference with
the generic thing.
It's sharing. A generic. It's just, and I don't know if they do share it for security reasons. Maybe they do. Maybe they have some way to do it. Right. I don't know. But the edge functions are a lot more limited because it's essentially the same environment for everyone. Gotcha. Whereas, the more traditional serverless functions, like the Lambda type ones, it's essentially a different Linux environment per se for every user. Now, services, they might optimize that and have some ways to save costs by reusing things or not spinning stuff up or whatever, but that's an implementation detail that we're not supposed to know about because, it's serverless, right?
Right. I get it.
Yeah. Does that make more sense then?
I think so, yeah, definitely.
Yeah.
Brings up other issues, but we could talk more about those later.
Like the fact that I finished my coffee.
Wow.
Okay.
That's pretty good.
I mean, I'm tired. I didn't sleep as much, and I'm like, it takes a little while for the coffee to hit. So I'm like, I wanted to hit while I'm on the show here.
Thomas, mine's hit. Sure.
How can you tell?
Oh yeah, I'm vibrating.
I see. I guess mine hasn't hit yet.
But hey, I wanted to discuss some of the positives and you to refute me on some of those positives. Is that
why? Are you thinking you might want to try this out?
I think so. I think I do.
Yeah.
There's certain scenarios that make sense in my mind. And,
yeah.
I could be wrong, but let's talk about them.
All right.
So I think some of the positives I see, like if I'm developing a system, I see a provisioning. So I know that you can connect to, say, for Vercel, for example, to your GitHub.
Yeah.
And anything I push to that branch, it will be provisioned by Vercel and be up and running. I like that. That's pretty nice. That could be a nice flow to where I test locally, I push to staging, I test on staging, and if I find it good, then I push to my production branch on GitHub, and then that would get provisioned out by Vercel and be running. So I kind of like that flow. It takes care of, me dealing with the infrastructure. It's
well, let me ask you this. How do you do it now?
Well, right now I would run, I would push it to production.
How do you put, what does that mean?
From Git, so I would do my work locally, then I would push it to staging, and I would test it on staging, and if everything was...
By push to staging, do you mean you're pushing to a staging branch on GitHub or something?
Exactly, and then I'd go on to staging.
How does that get deployed to staging?
All this, on my system, it's all mostly manual. So what I would do is, locally, I would test it, everything in my development branch, right?
Yeah.
And then I would push it to the staging branch, and then I would go to my staging machine on AWS.
Yeah.
And I would pull that down, restart the staging server, and it's running the brand new.
So to deploy your staging instance with new code,
Mhm.
you pull the code in from Git or something
Exactly.
and reboot the server to pick up the new code?
Exactly.
Okay.
So then we would test on staging,
Yeah.
and then similarly, if it's good to go, then we would merge that into production branch,
Yeah.
and then we'd go to the AWS. We have a series of production servers, and we would, on each one of those servers, we would pull down that new code and restart that server,
Yeah.
and it would be up and running. So that's currently how I would
So you
handle it.
basically do this sort of manual process. for
Manual
all of them.
process.
Yeah. And so you're like, hey, this sounds really nice. What you're talking about was you were like, hey, theoretically, it sounds like with Vercel, I wouldn't need to do those manual steps. I would just push my code to GitHub and it would automatically deploy it. Is that what you're talking about?
As one thing that would be nice. There's other things that I have in mind as well. But yeah, one of them, once I push to that production branch, it's taken care of.
Yeah.
So I like that.
Yeah. That makes sense. I guess I'm a little bit unsure how that is specific to serverless because
Mhm.
like the workflow that I use for both a lot of my personal projects and at various workplaces I've been at have been like for example with Heroku, I can set it up the same way. So I don't need, all I do is push my code to GitHub. Heroku detects I've pushed it to the master, the main branch, and then deploys a new version. And it can even be across multiple servers. It just handles this all for me. And if something goes wrong, I could log into the UI and click the rollback button to a different version, and it automatically does that.
Yeah, you're
So-
right.
so
It's
what
not
is-
specific to? It's not
Yeah.
specific to serverless. Definitely, it's not. It's just something that is useful in serverless.
Yeah. Yeah. So if that's not a specific advantage of serverless, it is, however, a feature though that is super nice, and Vercel and Netlify and other vendors provide those types of features. That makes sense, and that is something I recommend people setting up, no matter their environment.
Definitely.
What are there other things that you're interested in that are, you know?
Yeah. I think one of them that comes to mind, and this could be a good or a bad, is security. I'm assuming that they have people at Vercel, AW, or Lambda, whatever, that are experts in security, and they can handle the security issues around that. I like that as well.
Yeah.
I don't have to come up with a firewall. I don't have to deal with setting up Nginx. I don't have to do any of that. They're going to handle that. Whether they do it well or not, that's a different discussion. But
it's on them. And
it's on them, and I expect that they're professionals and they have an understanding how this works. So I like that.
Yeah. Well, let me ask you this. When your front end is making a request to a serverless function on the back end, how does that back end serverless function know it is authenticated to process that request?
Mm-hmm.
Like how do you handle that? Or is it just it'll process any of them? Like, I guess my question is, how do you ensure your serverless function is securely implemented from an application standpoint?
How does that work exactly?
So, I mean, like in a normal, more traditional architecture, right? You have Nginx or some sort of load balancer or something, and a user first hits your website. You serve them the code for the front end, right? They're running that code, and then they go to make like an API call, and so then that might go back to that Nginx, that load balancer, and then it's like, oh, hey, this is a backend call.
Exactly.
I'm gonna forward this request to the backend.
There's something
instance.
in the URL that designate this as a backend call.
Yeah, maybe it's /API.
Right. So nothing can get to the backend other than from that front.
Yeah, and you can set up like a firewall, so nothing else. Yeah, that's sort of the traditional way.
Everything but 443 and 80.
Yeah, exactly.
I think that's how we have it set up.
Yeah, so that's like a pretty traditional setup. But in this wild west of serverless, you can't set up your own firewall to do that. This thing could just be exposed to anyone on the internet.
But I would assume that they have something. I mean, if we can come up with a simple example of how this industry standard is, do they not have an industry standard? Are they not firewalling the back end and only allowing requests through the front end? I mean, are they not using some kind of standard that?
Well, but how would they? I mean, yes, theoretically you could, but that definitely adds another step. So like when we're talking about this, what is serving your front end then?
Mm-hmm.
And what is ensuring like the communication between these channels is all authenticated and happening properly? They do provide some tools around this. My main point is just that it's not a perfect, oh, I don't have to worry about security anymore.
Mm-hmm.
It just moves some of the security to a different layer. So it used to be, hey, I have this firewall set up, I don't have to worry about it. Now you have to worry about some of the security potentially at your application layer.
But do you? I'm assuming, again, that they have standards that work this scenario properly. And maybe you can look it up and maybe you can go to their website and find out.
So this is the thing. Like, let me ask you this. Have you ever used AWS?
Right. Mm-hmm. Yeah.
And would you call it really simple, straightforward, easy to understand, high quality documentation?
No.
All right. So do you see what I'm getting at?
Right. Okay.
So yes, all this stuff exists. And especially if you're using something like Vercel or Netlify that is supposed to handle this for you, it could potentially be less of an issue.
Mm-hmm.
But yeah, these tools do exist, but you have to know how to use them correctly.
Right.
Which means you got to understand the documentation, got to understand how to set it up right. It's like the classic scenario where you join a company and you find out everyone is sharing the production SSL key to connect to the database, right?
Right.
And it's not that there isn't security in place, but it's how you use that security that matters. If everyone's sharing this key, you have a lot less control over who has access.
Yeah, I guess I don't know if it's a valid point, I suppose. But is it a valid point to get into a car that I bought and assume that the brakes work? I mean, I should be able to assume that. I don't need to know how the brakes necessarily work. If I'm going to this service, I'm expecting to know how it works.
I think it makes sense, but you still have to understand how it works to ensure you are utilizing it correctly.
Yeah, I think in a critical system, you probably would.
And I think this is too where it gets more interesting. Like, it's not a monolith anymore. What if you have one function that's calling another function, but maybe some of these functions are admin specific functionality that not all users should be able to call? Again, this isn't a new thing. You have to deal with these problems in a non-serverless architecture too. The difference is the APIs that are available are potentially different. And so you have to understand how that works. And because there's no other firewalls sort of involved necessarily to wall that off, you can't potentially rely on features that existed that you took advantage of in a more traditional instance.
Yeah,
so
I get it.
So yeah, I think you're right. It eliminates understanding some types of security. Like you don't need to understand some things that we had to understand in the old days,
Right.
like my gray beard isn't quite long enough at the moment, but you get the idea. So, okay. So security, we talked about that. Are there any other reasons that you were thinking about doing serverless?
Yeah, I guess scaling seemed like another potential plus. And the reason currently the system I have, maybe we would add another server, or remove a server. Behind a firewall. Or
scaling. Everyone we want to just scale, right? Like you don't want to mess with that, right?
No, and I think that would be, if that was handled automatically, that would be great.
Like what? Like what if you go viral and your site just goes nuts, but you're sleeping and you don't know it and it falls over?
Yeah, I don't like that.
You don't want that, right? You don't want that hanging over your head, right?
Yeah, no.
So serverless with that that fix that?
Yeah, I think so. I mean, I think it's a potential feature.
Or that's what people say,
That's
right?
what people say.
I mean, it's funny that this is what we're getting to now, because I feel like this is the main thing people talk about with serverless.
Well,
is
yeah.
infinite scalability, right?
And as I'm saying it, I mean, is that really what's happening to people in the world? Is going from nothing to, 100,000 users in a week?
I mean,
I don't know.
how long have you been sort of in the software industry working on web applications?
Maybe
Or websites, even?
like 15, 20 years.
How many times have you been in that scenario?
Never.
Well, I have the same answers. Okay. So there's been times where we've had traffic go up, but it's never like, and obviously that exists. It has obviously happened, but it seems to be pretty rare.
Yeah, and I think honestly, if you had the potential of that kind of great growth, I don't know that you would go to one of these services. You'd probably have a team, you'd have an investor, you'd have a team of people that were handling the infrastructure and building it from scratch.
Yeah.
How I think
But I mean, what if you're that solo developer just starting your own startup and you go viral?
These are good problems to have.
Yeah, totally. That's what I'm thinking. I'm like, man, if that's your problem, then
we'll
I think
figure it out.
Yeah. But I mean, the big thing is we should talk about it though. Is infinite scalability. Yeah. Is it infinitely scalable?
I would say so.
I mean, generally, within reason. There's always limitations. Like I've heard about people that have, implemented serverless and actually hit scaling limitations related to serverless, but they tend to be different and they tend to show up often maybe a little bit further down, versus say running a super minimal virtual private server or something, $5 a month. Maybe you'll hit your limits there a little bit sooner than you would on a serverless architecture.
Right. Yeah, I don't know. The more I talk about it, the less attractive it gets, even though there are positives to it.
Yeah.
I just think when I think it through, why not start with doing it yourself, I guess is how I feel about it.
I mean, it seems like you have experience, doing all these things. Mm-hmm. If you didn't have experience, if you didn't know how to set up Nginx, if you didn't know how to run Linux, if you didn't know how to set up a firewall, if you didn't want to deal with rebooting a server and keeping it up to date and tracking security vulnerabilities in the underlying system, all these things, would it be more appealing to you then?
I think so. And I think that's probably the sweet spot for this thing is maybe like an MVP. You want to do something quick, set it up. Or if you didn't know and didn't want to know, like this is not what I do, but I do want to program. I do want to build a system.
Yeah.
This could totally work. And you know, if you run into the issues that we described, some of them, if it's that popular and at that point you can get off of it or move to something else or do something, you can get somebody to help you at that point. So it's probably a good on ramp for somebody for sure.
So I would agree. So that makes sense. So in terms of the scalability, it makes sense. But I guess this is where it's funny to me, because what you're describing is the situation where scalability doesn't matter. So if one of the primary benefits to serverless is scalability, and the only time you should use it is when scalability doesn't matter, why are we like, why is that a benefit then? Why wouldn't it make more sense to start on a regular, like let's say you maybe don't know how to manage all this, but you could use Heroku, and Heroku will let you hook up your GitHub and deploy stuff, and you need to know how to manage all this, right? Why not start there and migrate to serverless once you get more traffic? Because if the whole point is infinite scalability, why wouldn't we do it that way? Wouldn't that make more sense? You do the less scalable thing, which is the old way we used to do it, and then you migrate to serverless when you need infinite scalability. I'm just sort of playing devil's advocate here, maybe,
and I think you're right. I think Heroku is probably more attractive than serverless, at least in my in my mind right now, because I think you mentioned that Heroku also has features to where you can scale. And knowing that Heroku, there's some of the limitations that serverless has, where Heroku doesn't have those limitations. We could talk more. I think it probably is more attractive in any way I can think of.
I
in
think
terms of price as well.
Yeah, and I think we should touch on some other aspects too. Like, what does scaling mean?
Mm-hmm.
There's two primary kinds of scaling, vertical and horizontal scaling, right? So vertical scaling would be, I've got like a small Linux box with a gig of RAM and one CPU, and I get more traffic. I'm going to just make that a more powerful machine. This is the sort of long-standing traditional way of scaling, right? Like you need more processing power, you get a bigger machine,
right?
More cores, more RAM, right? And you just have your one web server running on there. Or maybe you've got two web servers. One is a failover. It just sits there waiting in case one fails, but it's not really doing anything otherwise. So basically, it's just an architecture where you have your monolith running on this one thing. And to scale, you just keep making that machine more and more and more and more powerful, or optimizing your code so it fits on the machine it's running on. Anytime you have scaling issues, you go, okay, what's slow? Well, let me make that function faster. Let me make that, right? So that's one way of approaching. We call that vertical scaling. Then we also have horizontal scaling, right? That horizontal scaling is much more like serverless. That is where instead of making one machine bigger, we add more machines and distribute the work across those machines. That would be more like serverless, right? We're distributing the work across infinite number of function invocations or machines, essentially, right? So I think that's another very important thing to talk about, because in my experience, vertical scaling is way easier than horizontal scaling. No matter whether it's on Heroku where it auto scales up. Going back, this all ties in, actually. I know I went on a long time about all this, but it does tie into that. Yeah, that Heroku has a feature where it can detect, you can configure it to be like, hey, if the average response time hits this threshold for this long, add more servers and distribute the requests across those servers, right? Or, however you want to do it. And it can up and down scale based on that. So that's horizontal scaling. It adds more of these machines. I find that to be a lot more error prone and a lot more complicated than vertical scaling. And I think it makes sense, because vertical scaling, you don't actually do anything different. Your code is exactly the same. All you do is put more money into the hardware.
Right. But in this case with Heroku, it's magically handled anyway, so it's essentially the same.
No, because with Heroku, I'm adding more machines.
But you're not doing it on manually. You're not.
Yeah, doing it manually, but it adds complexity to my application, because once I've done that, now I'm running into the case where I have resource contention. Where what if a request comes in to two different machines and they try to modify the same record at the same time? That's now something maybe we didn't have to worry about before. Or if we did have to worry about it in our vertical scaling, the solutions are much simpler. So if we have resource contention and vertical scaling, we could set up a basic mutex or something, right? To just control access. Really easy, really simple, really fast, really performant. But if we're horizontal scaling, whether it's on Heroku, adding more machines, or whether it's serverless, we now have to somehow manage resource contention.
Right.
And so that's where I think, I find vertical scaling to be a lot easier. All right, I had to take a quick break, but we're back. We're back on the React show. Yeah, time to react. I definitely haven't had too much coffee. I'm definitely fully. Now, my problem is I'm kind of brain fog, like a little bit tired just from not sleeping enough. But then the coffee,
to hold back too much energy right now. I don't want to sound crazy.
So we were talking about like resource contention, right? And it seemed like you were curious about what I don't know. The look I was getting on your face was,
Right.
what the heck are you talking about? Like, why would there be an issue, right?
Well, yeah, when I was thinking that through when we took our break, the issue to me is what's the scenario where this could be an issue? For example, we described like a pay situation where a customer maybe hits pay. Say you have 3 servers behind a load balancer. It's ramped up to 3 because of start over.
Ramped up to 4? Is that what we're saying?
Right. So anyway, we have 3 servers
Yeah.
behind a load balancer.
Yeah.
I hit pay, it goes to 1, it begins to pay. Then you're saying if I hit second one real quick, there's a network issue. I hit it a second time.
Yeah.
Potentially we could have it trying to pay on 2 servers at once.
Yeah.
And then we went down the road of, well, that would be transactional code, I would imagine, inside that method. Well, first off, on the front end, obviously it would be grayed out and not let you do that.
Well, but what if that front end engineer didn't understand use state in React and made a mistake and it didn't gray out?
Right.
Or it did gray out, but they did it in the wrong order, so there's a slight delay, or
right.
the animation broke, or
a hacker was bypassing it, right?
Yeah. We can't rely on the front end, basically, is what we're saying.
Exactly. But that scenario you're describing, if it's, say that method's transactional, I would assume it would lock the database table, and various things would happen throughout that transactional method that it wouldn't be a factor if this happened.
Well, what do you mean lock the table? What do you mean transaction? What is this language you speak of?
Well, like in Rails, you can mark some code transactional.
Yeah.
And inside that block, it would lock the table, for example.
Yeah. What if I am not very experienced and I didn't know about transactions? Or what if I made a mistake? What if somebody had abstracted that code and I was refactoring it and I thought the code I was calling set up a transaction, but turns out it wasn't?
Mm-hmm.
Could that happen?
Sure.
What are we going to do then? Now we
might get charged twice.
So that's my point is,
right.
Yes, theoretically, nothing's new under the sun. You can handle all these issues. You know what you're doing. You can handle it.
Right.
But my argument is that vertical scaling tends to be easier and simple to solve those types of issues. You can solve it no matter what, but it seems like horizontal scaling adds complexity that isn't necessarily as easy to solve as it is when you're doing vertical scaling. And I think a great example would be if you were operating on a file. Like, let's say a user, a great example is Figma. You know Figma?
Mm-hmm.
So multiple people can operate on the design of something at once. Let's say it's like Figma, but we're like manipulating an image together. And we get 2 different requests that manipulate the image in 2 conflicting ways.
Right.
Handling that in a monolithic application is relatively straightforward.
Yeah.
Handling that in something where it's distributed becomes a lot more difficult. Like like in our serverless example, how would you handle that? Like you've got your serverless function that resizes an image, but also you have another serverless function that will, make the image black and white. And let's say you just happen to end up in a scenario because of networking issues or whatever it happens to be, but you're trying to do those 2 different operations to the image at the same time.
Yeah. I mean, some of this seems theoretical, but it is. I could envision scenarios where it isn't.
Yeah, and I mean, again, if you don't have very many users, you're unlikely to hit this.
Right.
But
it is a factor.
Right, but the whole argument, the main argument people often have for serverless is that it's infinitely scalable.
Right.
So let's take the extreme case of you are trying to take advantage of that feature and you've got tons of users using your system.
Mm-hmm.
These types of issues are way more likely to occur the more users you have.
Agreed.
So now we're in a situation where this is more likely to occur. It also seems kind of more annoying to work around. Like, how are you going to handle this?
Yeah, you're gonna have to be aware of it and think about it, and
Well,
have mutexes on things.
exactly. And this is what I really wanted to talk about. You just said the key word. You're going to have mutexes. And for those of you that don't know what a mutex is, what we really mean is you just have some sort of something, some barrier, something that ensures more than one thing can't operate on something at once, right? So what I think often happens is the approach people use to solve this problem is they start creating queues. So, hey, we've got a number of operations to perform on this resource. We'll funnel it all into some queue. And like basically you're going to set up like a worker type situation, right? So, hey, all requests to edit this resource go into this queue, whether that's a database table or whatever it happens to be. And then some other serverless function pulls stuff off the queue and operates on it, right? Are you seeing the issue yet with our infinitely scalable solution? What's the issue?
Everybody's got in line and they're waiting to get access to that thing.
So
close it down.
Exactly. And so this is one of the key things I think is important to understand when people talk about infinitely scalable serverless things. Yes, theoretically, we can infinitely scale up all these functions, whatever, right? But we still are always going to have to deal with the fact that sometimes the order of operations matters. Sometimes you can only do something once, and then doing it again shouldn't be allowed or should depend on what happened before it. So all those things start becoming more complicated in this horizontal scaling.
Yeah, no matter where you go with this, there's a trade-off somehow.
Exactly.
You know what I'm saying?
Yeah. Yeah. So yes, theoretically, serverless, in terms of its infinite scalability, there are certainly certain types of problems that it's more applicable to than others, right? So like maybe your application, the types of resources you're dealing with, none of these are problems.
That potentially could be true. Definitely.
Right. There's certainly scenarios where that's true. But it's like everything. It's like a scale. There's probably certain problems on one extreme end, and there's problems on the other extreme end. Like maybe you're, the classic example. You're a bank. Like reliability and ensuring the same transaction doesn't get replayed twice is super, super important.
Right. Yeah. It's a different whole different ball game.
Yeah. So like everything, it's important to understand the trade-offs involved and when one architecture makes sense over another, right?
Yeah, as we're talking, I thought of one other point that maybe, I don't know if it's a value or not, but it's a positive that I've seen in the industry, that if you're working at a company, they want to have somebody to blame. You know what I mean? So if you have Vercel, or if you have a Lambda or something else, or setting up your system, they like that because this service, you can call them and put it on them, and that's a real thing.
Yeah,
you know what I'm saying? From what I've seen in my industry, they want somebody to be able to call and say,
Absolutely.
"This is the issue. Where fix it?
Yeah.
What's going on?
Tell
me if it's me. Tell me, but I want to know what the problem is."
CYA, right?
Yeah, it's really true. So that could be an attractive point for somebody.
Yeah, absolutely. That is classic in the business world, right?
Yeah.
Now, I'm just curious, as an engineer, how do you feel about that when you have to go to the vendor and wait for them to resolve it?
I don't like that at all. I really don't.
What, you don't think it's faster? You couldn't just resolve it yourself?
Probably could. But just even if you have real good customer service with them, a real good sort of option, it's always not that fun.
And it's like one of those things where that interaction, even like you say, it's really good. There's so much overhead involved.
Yeah.
Like they've got their own team, they've got their own ticketing system, they've got their own processes, their own way of communicating. You've got to communicate to them and blah, blah, blah. And like,
yeah, it's not always the best for the engineer, but some executives want that layer.
Yeah,
they definitely do.
Well, even some engineers, because depending on your culture, you might want that extra protection so you can go to your boss and be like, sorry, boss, can't do nothing. I'm waiting on Amazon to get back to me, you know? I don't know why I got this weird accent.
Right. And they may be trying to put it back on you.
Yeah. Oh, you know the classic dits, don't you? Oh yeah, we're waiting on the AWS to get back to us. What are they going to say when they get back to you? Oh no, it all looks fine on our system. It must. Then you're like, what? Are you kidding me? And you go back. No, it's definitely a problem with their system. Then you go back to them. And
yeah, that's not good, but that is a factor I've noticed.
Yeah. So is that what makes serverless a little bit more appealing to you?
No, I don't like nothing in here. After speaking through all that, nothing in here really floats my boat. Other than, I would say if an MVP, or if you have a small system that you want to try to get up and running, that might be attractive. But barring those two things, I probably wouldn't use it.
Really?
No.
I mean, are there any other things you've thought of that seem attractive about it?
Not really. That's probably
yeah.
That's about it.
I mean, but you're also coming at this from graybeard territory, right? Because and like you and I were talking about this earlier, like when we got into web stuff, serverless didn't exist. It was not even a twinkle. Maybe it was a twinkle in somebody's eye, but not any eye that we heard of, because Facebook didn't even exist back then, right? So we we had to learn how to configure all this stuff and set it up. And let me ask you this, Richard. Have you ever had the experience where you're like, oh, I need somehow to serve this thing and route requests. I guess I'll do a web search. Oh, this thing called Apache. Have you ever had that? And then you started messing with XML configurations, and it was beautiful, right? No problems.
It wasn't at all. Trying to draw in what are the plugins or whatever.
Yeah. Oh, yeah. And then they upgrade the plugin, and then.
No, I never really liked Apache, to be quite honest.
Yeah, but now we got Nginx, but it's the same. It's the same thing. You have to know how it works. You have to know how to configure it. But at this point, you put in the time, and you're like, okay, I know how it works. I know, I've seen this error before. It just means I didn't X, Y, Z, and
Right.
Like we have that experience. Like for me, my main systems have been Linux since forever. Like technically I'm using a Mac, but everyone laughs because I run a Linux virtual machine on my Mac because I hate developing on Macs.
That's hardcore.
I know. I cannot live without Linux, but I've told this story many times, so I won't get into it. But even when I was a kid and I got my first computer, I put Linux on it instead of Windows XP at the time.
Oh yeah.
I have been in this.
Did a lot of that too.
Did you?
Oh yeah, 100%. And I've learned that's too hard of a route to go down.
See, I wouldn't doubt it. So I'm like to me, Linux and managing that stuff is I don't even have to think about it, you know? So my perspective, and I think your perspective on this, is different than somebody that's new to programming and new to React.
I think that's true.
Yeah. I think that's when we were first looking into talking about this, and I was trying to understand why some people were so excited about serverless. The more I talked to people, the more it seemed like the excitement is just more around the fact that they can just click one button to connect it to their GitHub repo.
Yeah.
And not have to know how to do any of this.
I see the attraction in that. But and it still is viable, I suppose, if that's what you wanted to do, and it's that easy, and it's it does work. So you could go down that road. I think one thing we talked about that was important. Maybe you go down that road, but if you look out for vendor lock-in where they're trying to get you to use their specific features,
but they're not going to do that. I mean, not Amazon, not Google, not Microsoft.
They got
right?
MBA guys from Harvard sitting in rooms thinking of this stuff. Okay, they're going to come up with it. They are going to do that.
So what kind of vendor lock-in? Like, what are we talking about? Like, what's the situation?
You mentioned the edge. I always call it edge caching, but it's not edge caching.
Yeah, that's a different thing.
Yeah.
Although that also has vendor lock-in, I'm sure.
Oh yeah, I'm sure. But if you want to get around the cold start stuff, right, to where you hit it first and it's slow, and then subsequent hits it's faster.
Yeah,
they'll offer you a feature if you put their code into your code specifically, like directly in your code. It will work around that cold start stuff. So I feel like you get enough of that in there, and you have enough classes or methods or anything with that code in there, and you try to back out of that, that's going to be a whole nother project that you're going to try to figure out, and maybe you're not able to do that.
Or like another case, I think very common would be on the database side. So yes, you've got your infinitely scalable server functions, but is your database infinitely scalable? Right. Did I say scrollable or
no,
scalable?
No, you said it. Scalable.
Oh man. All right. I'm not tired. I'm like imagining I said. So yeah, maybe you've got your database hooked up and you're starting to run into bottlenecks there. What if your vendor offers you a type of database that is also scalable and you can just plug it in? Should you do that? Like, is that what you mean?
Yeah, I mean, should you do that? Well, I mean, you can, and that's fine if you know what's happening to you. If you're okay with that, then yeah, do it. But
what's happening to me? I mean, they are like, what? I guess what is the risk? Like, if you were to quantify it, like if I decide to go down that route and start using more services with whatever vendor it is, whether it's cloud storage or they all have a whole bunch of different stuff. Maybe there's an image processing service. There's a job queue service. There's what is it? We got like beanstalks, that's old stuff. I know I'm an old person, but yeah, there's lots of fancy stuff, right?
Yeah. But like, for example, what if you go down this road, right? Yeah. Everything's working and you keep adding in these specific services, and then you're at the end, you start scaling and your company starts growing and making money, and then you realize it's not working. It's like, this is not working for me that well. It's expensive. It's actually, when I think about it, it could be faster if I took it onto another service. And now you can't get off that service. So you're stuck paying for this expensive service that's not as fast as you want it to be. The system's just kind of stuck in limbo.
Have you ever experienced this or seen this?
I mean, I'm right now I'm on an old AWS system that's very old and very brittle, and it's hard to get off of because the tools don't exist. It's like it's a lot of manual work to get off of this.
Yeah.
And so, and like we talked about before, when you approach AWS, try to get them to lower the costs, they know the situation you're in. And they're like, nah, we can't do that. Here's what you could do. But came at them, like, hey, I can move quickly off of this. And they probably are aware. They probably go through your system and see what kind of services you're using and see how
tied in you are.
If you're tied in, the answer is no. If you're not tied in, well, it's maybe.
Yep.
I'm just saying, you could go down this road and you get stuck in a dead end that's hard to recover from or hard to get out of.
Yeah. It sounds like you've been there, and I have to say, at pretty much every place I've been hired to work at or I've worked at in some fashion, been in this similar boat. Almost all of them.
Okay.
There's one place I worked in that wasn't, but basically all of them are in that boat where migrating off of the vendor they're on sounds like such a costly proposition from an engineering standpoint that it literally isn't even mentioned. Like in a lot of cases, the places I've been at are less tied in than we're talking about. Like even if it's just EC2 and a few other things, right? Like, it's amazing how little it takes to the point where you're like,
that's a good point.
Wow, if we have to migrate off this, wait, do you remember how that one thing was configured that does this and routes stuff
to you? There'll be several things like that no one's aware of over the years that's just sitting there working, and you're like, wait, how do we deal with this Redis server that's also doing these other things, and then you can't get off? It's really hard to get off of it.
Yeah, exactly. You're like, wait, why do we have this thing again? and somebody's like, well, I think somebody said it does this, and I don't really remember, but I remember one time it went down and it brought the whole site down, and
Exactly. And it's going to be on you. So
and so then you're like, okay, so migrating off this, we'd have to understand how all these things work, how they were all configured, what depends on what, why it depends on that, And even with a something where you're not really that vendor locked in, it can get really complicated. But once you go down the path of like using vendor specific APIs to accomplish things, that's like a whole nother level.
Yeah, and that's their game, is make the on-ramp easy and give you a free tier. Add vendor lock-in, and then now you're down the road. Good luck. It's true.
Oh, it's absolutely true. Like even like Heroku, like I was at a place not that long ago that they used Heroku, and the bills, like, man, they were high. Like they were basically paying, like our Heroku bills would have covered an entire engineer's cost.
Yeah, that's crazy.
And it wasn't even, we didn't even have that many users. And so the higher ups came to us and they're like, hey guys, like we can't, like we got to do something about this, where this cost is killing us. Like we could have a whole nother engineer here. And we're like, great, can this engineer be dedicated to managing the infrastructure? And they're like, well, no, we want more features, And so we went and we came up with a plan to migrate off. And it was like, the only way we're comfortable with this on the engineering side, it's going to take us probably like 6 months and like a lot of testing and a lot of like, and yeah, it never happened because they're like, oh, well, I guess we'll just keep paying this.
That's what happens. And you'll just tuck it away in your brain as like someday.
Yes, it's absolutely one of those things. It's totally the someday thing, isn't it? It's like every engineer on the team, it's probably like written in the README somewhere.
Right.
We're hoping to move off this someday, so don't do X, Y, Z.
Right.
Yeah.
It's all mixed in the code.
Yeah. Oh, yeah. There's probably comments throughout the code like, oh, this really should be moved off this specific API so we can finally move off this. And
yeah.
It just doesn't happen. It's costly. So I think like if we're trying to like wrap up this specific point, you said, hey, I might do this for like an MVP or something, right?
Yeah.
Well, what if you start getting some traction and it starts growing? What are you going to do? Are you going to keep using Vercel with the default infrastructure that's based on serverless functions? Like what? Like when should this be evaluated? Should you just not do it because the expense of vendor lock-in is too high? Or is there a point where you would be like, okay, we need to move off of it? Or how would that go?
When you were saying that, I was thinking maybe that's not even good advice, the MVP. Because if you get it MVP'd and it's working, you're going to get hit with, all right, we want this feature, this feature, this feature. Are you now going to take that, go over to something like Vultr or whatever, and manually rebuild this and do it? I'm probably not. I'm going to be, okay, well, they want all these features. Let's get working on this.
Exactly. And this is the situation. Okay, we could add this feature that this potential huge, it's always the huge customer, right?
Oh, yeah.
It's always, such and such big name, such and such huge customer. Right. They will sign on with us. We just have to add this feature.
Yeah.
So we can add this feature, get this big name person, or we could migrate to a new infrastructure that will probably save us time and headache down the road.
Yeah, when I won't even be here as an engineer. It's probably not going to happen,
Yeah.
Unless it's your baby, you're probably not going to do it.
Yeah.
You know what I'm saying? It's not going to happen.
And this is, I think, gets into something that we when we were planning for this episode, we talked about a bit, which is on one level, a lot of this technology is super exciting to me. And we didn't even talk about this, you and I, but I want to say like from a technological standpoint, I really like some of the ideas behind serverless, to the point where, like, I've talked about the operating system that I worked on before. Part of that was my whole, like, I have a much larger vision for like the future of computing, right?
Right.
And one of those visions is coming up with a way that we can naturally program software so that it can naturally be broken down into parallelizable chunks.
Okay.
So that if you want, it would just magically get distributed across resources.
Right.
So the level I thought of it most immediately was on modern systems with multiple cores on our CPU, and we distribute work across them. That's horizontal scaling at an application level. And I was like, it would be way cooler if I could just program without thinking about concurrency, and the language or libraries I'm using would just automatically divide that work up across all the cores on my system and maximally utilize the resources. That's the same exact idea as serverless, right? Like we are horizontally scaling across servers, our workload.
Right.
So like from a technological standpoint, it's really exciting to me. And I actually believe it is potentially a way of the future. So from that standpoint, I'm very excited about it. Like, I feel like when you first heard about it, I feel like you were feeling that too. Like, yeah, this sounds really exciting. Like, oh, that makes perfect sense. We could more efficiently use our hardware resources, right?
Yeah, I get caught up on the, I'm a technologist. I like technology and I like thinking about that stuff. And I saw that Lambda and it triggered in my mind less logic and more excitement,
Yeah.
and more technology excitement. And I'm sure that happens to other people. It's exciting. It's interesting.
Yeah.
But when you analyze it and you're like, it makes no sense. In a lot of scenarios, it makes no sense. Only in certain scenarios. So, yeah, I mean, I don't know. That's just, I'm susceptible to that because of the way my brain works. I like technology.
I when I first heard about it, I was like, brilliant. Sign me up. Right now, I want to do that. Like, I don't want to have to. I know how to do Linux. I know how to do all this stuff. I don't want to do it all the time.
No.
I would much rather just write my application code.
100%.
Like that. Like honestly, from the technical standpoint, that does sound like the future. But I don't feel like we're fully there yet. There's so many issues from it's not actually infinitely scalable because you'll have those issues we talked about before with resource contention. There's vendor lock-in. There's all sorts of issues that I feel like just haven't been fully resolved. Like ideally, I think in the future, it would be amazing if we never had to worry about this stuff again. We could just program applications. Like that does seem like a good future.
Yeah, 100%.
I think right now we're at the point though where a lot of the trade-offs are around the fact that I think this whole idea, this whole abstraction is got two main issues. One, it's not fully figured out, fully baked in. We haven't figured out how to do all these things quite as well as they should, especially with like resource contention and that kind of stuff.
Yeah, that's an issue.
But then you have the vendor sort of specific lock-in issues that also annoy me.
And as you're saying that, I'm starting to think like, and we could talk about this on another episode, but the way Docker works, at least in my mind, it seems like that's kind of a fusion of couple different areas that makes sense to me. But there is some overhead to deal with to make that happen that may not fit into the same people that are going to be using, say, Vercel. But it's worth talking about. I think it's pretty interesting, actually.
Yeah, and I think, in general, a lot of this is about where is the complexity of your software.
Exactly.
Like that complexity could be at the configuration level, the sort of orchestration level. There's all sorts of tools, Kubernetes and all this stuff to like manage and orchestrate and configure systems. Or kind of the more serverless way is, you end up using some of these tools, I think, for that. But generally, the serverless approach is more that I'm losing my mind here. The complexity. Yeah. The word I was really looking for. The complexity gets moved into your application code layer, which might be perfectly fine. It depends on the situation, depends on the environment. But that's the important thing to understand is that complexity, some of it is inherent given the current limitations of our systems. So the question becomes, where do we put that complexity?
Yeah. Well, I thought instead of saying complex, you were going to a word that might be offensive, but a cop out. Like it's like if you go down this road, aren't you kind of copping out of learning of what's happening? So you're like, I'm going to let it be auto magical, but I'm going to have to pay the price potentially down the road.
Yeah,
I don't understand these things.
Well, I mean, that's in one sense absolutely true, but also a price that is worth paying a lot of the time. Because like let me ask you this: do you know how every single layer works on your Linux machine?
No.
I mean, that's a cop out. You should learn it.
You're right, but some of that stuff, like I made the description before, or the comparison to brakes on a car. You just have to assume that it works.
Yeah,
you know what I mean. Like I can't know everything.
Yeah,
I want to sort of specialize in what I do.
Yeah.
So maybe I think maybe at this point, Vercel, things like this, it's not where it needs to be, but they're working towards that.
Yeah, I think it's one of those things where and I do know some of this exists. We didn't really talk about it, but like there are people working on open standards for these types of things, or even like we've talked about serverless being run by Amazon or Google or Azure. How do you say that? Azure?
Azure.
Azure?
Azure. Azure.
We've talked about other people doing it, but why can't I run my own machine? Like what about this? What if I had my own machine and I wanted to run 15 different websites on it? Oh, guess what? I do this because I self-host a lot of stuff, right? Well, what if I did all those as serverless? What if everybody wrote their applications as serverless?
Yeah. And
I could just distribute that work to my own machines or my machines and your machines. What if you and I wanted to share the load, across our stuff, Like,
well, I think said generically, the concept is awesome. If you could make a serverless situation, you could provision it to any machines anywhere in the world, and it just works.
Yeah.
Sure.
Yeah.
But we're not there yet, I suppose.
Yeah, I feel like that's the disappointing part. And I think that's also disappointing to me because, I mean, it's been 10 years, I guess, since AWS Lambda came out. Like, I mean, has that situation gotten better? I mean, I do know there are open source projects that try to do this, but like, they don't seem to be what people use. It's not these things are not what people use. So I think that's what's frustrating to me. Like, I wish there's a way to.
And we don't know how much energy is being put on these things. Maybe they work well enough, and somebody like AWS, they're not going to sit there all day working on Lambda. If it's not a benefit to them, that may be an offering they have. They may be working on other things, and Azure or Lambda is going to work as well as it works now for a long time.
Yeah, that's true as well. I think, yeah. I mean, I think that the net result of us talking about this, I'm like, on the one hand, next time I'm doing some throwaway, some prototype, I'm starting something, I'll probably use one of these services because I'm feeling lazy.
Yeah, because I was just thinking in my head, if you want to set up something in Vultr, it's pretty easy, but you do have to go through some scenarios and iterations to make it work. But if you use something like, Vercel or some other service, Lambda, it's pretty easy to get it going. Especially if it reads right out of your GitHub and provisions that, and it's working. I mean, geez, that's pretty nice.
Yeah. So
hard.
Yeah, it's hard. I think it's one of those things that if you can invest the resources into at least understanding more about alternatives, it's certainly worthwhile, I think, in the long run. Of course, like, if you're just learning this and, I would say it's much better to get your website up and running 100%. Than to mess with this for 3 months before getting your site up.
Back in the days, you'd be like working through trying to get the server set up, and you're not getting it set up. You're not making it work. And maybe it won't happen.
Exactly.
But if you could use this and you can get it happening, and you got your site up, what scenario is better?
Yeah. So yeah, so I don't know. What I was really trying to get to is, all that being said, the more we talk about this, the more I am excited for the technology in general.
Yeah.
Like, the more we talk about that, I'm like, oh wow, what a dream that would be. Like, and it makes me want to go back to working on three LOS, and because like I don't know, like, it was so cool to like think about conceptually how we could create that system. Like, do you want me to like give you like a 3 minute like
give it to me, man.
So I actually did work on a model where this would work, and I haven't like fully proved it out. So maybe, so if you can find some flaws in it, you can.
Okay.
But think about this. So do you know like the pure functional style of programming? So pure functional means your code has zero side effects of any kind.
Okay.
So like, let's say we have our add one function that takes as input argument A and returns A plus 1.
Gotcha.
That's a pure function. I haven't interacted with, I haven't read from the hardware. I haven't written to the network. I haven't, done anything. I didn't log anything. I didn't do anything, right? Pure function. That's pure functional programming. You can take that and distribute it across all the resources, and you will never have any problems.
Right.
Because there's no side effects. So the entire crux of everything we're talking about is actually side effects. Side effects are what makes code complicated. But the flip side is, side effects are what makes code useful. Your add one function has no purpose to the world if the user cannot input a value into it and get a result in the real world in some way or another, whether it's being displayed on a screen or set in a database or whatever, right?
Right.
So I was like, okay, what we really, like, if we could program our entire program purely functional,
okay,
then we could scale it across all the CPUs on our machine, all the CPUs on your machine, everyone's, without really doing anything complicated. Just run this code, right? It would work. That would, right? But we haven't solved the problem of side effects.
Right.
So what you could do is, if you want side effects to occur, you could return the side effects that you want to occur. So like, for example, let's say I want to display a character on the screen. You could modify the memory on your system, or call the graphics driver or whatever to display that character, or call console.log, which would in effect do those things under the covers, right?
Okay.
But that would work.
Right.
That's how you would normally do it. Hey, I want to put something on the screen. I call some API. And if it's in the web, you'd call some web API to manipulate the DOM or whatever, right? And that would have side effects. Those are side effecting code. Well, what if instead I returned some sort of structure that told the system what I wanted it to do? So instead of actually modifying what shows up on screen or modifying the DOM, I return something that says, hey, I would like to write this character to the screen.
Okay.
And then something else handles that side effect.
Like a meta structure would come back.
Yeah,
something
exactly.
else would read that and deal with it.
Yeah. And so your actual application code would never directly have any side effects. Everything you ever wanted to do, whether it's reading from the network, writing to the network, files, whatever it is, it's all the meta structure that describes how or what you want to occur. And so like, your code can return that. So all of your code is purely functional. Every single time you pass it the same input, it gives you the same output, no matter what. No side effects. Oh, guess what? Now I can scale this across everything.
Okay. I like that.
Yeah.
Interesting.
And it's an interesting idea, right?
Yeah. Yeah. But does it exist?
I mean,
it sounds like it exists. But,
it's complicated,
right,
because the mechanism for resolving all of those side effects that you do want to occur, there's two primary problems. One is performance.
Yeah.
How are you going to resolve all those things in a performant way?
Yeah.
And two, it kind of gets into an implicit thing we deal with in programming all the time that probably needs to be made more explicit, which is time.
Mm-hmm.
So side effects inevitably interact with time. So like if I display this character and then call something else that wants to display another character, it's implicitly doing it later in time, implying that it goes maybe the next character further on the screen. So it sort of opens up this can of worms of like, how as programmers do we start dealing with that? Like, do all our functions need to take a separate argument that's like a point in time and there's like some bookkeeping around it so that the thing that later on resolves all these side effects knows in which order to resolve them?
I see.
So I think, and a lot of people have done research on this, and that's why it's so exciting to me. It seems like a possibility, you know?
But if you had two virtual machines and you did pure functional programming, it seems like you'd pass the metadata and that virtual machine would take that and the virtual machine would run that metadata and do everything in there where the functions are still purely functional.
Yeah.
That would work, right?
Yeah, absolutely. Yeah.
Hard to conceptualize.
Yeah. So you could distribute your processing across anything, any size hardware, anywhere in the world.
I mean, it seems like you could test this now.
Yeah, I have written some code for it.
I should have known that.
But I think it's interesting too. More like if you're still following, you're probably like, wow, this is off the rails.
Right.
But you want to know what's interesting? Let's go back to React. React, in a sense, operates in this way because in React, you don't manipulate the DOM directly. You just return JSX and then something else resolves the actual changes that need to occur.
Right. Yeah.
And
I learned that from your book, by the way.
My book?
Again.
Which book is that? Are you talking about Foundations of High Performance React by Thomas Hintz?
Yeah. That guy knows what he's talking about.
Yeah, I mean, if you guys do want to learn about that, you can find the book on thereactshow.com.
Yeah.
But yeah.
Great book.
Yeah, so thank you. So yeah, it's really interesting because we actually are applying some of those things, and it actually in some ways does make programming easier.
Well, see, as a side note, and I know you have other opinions, but first thing that comes into my mind is come up with this conceptualization that you just described and ask ChatGPT what it thinks. I would like to see that. Like, what are the ramifications? What benefits do I see here? Do you see any complexities? You know, like it would be interesting.
Well, I mean, yeah, we could ask ChatGPT, but the fact is, there are actually research papers done on this. We could go to the source.
It's good to get a high level bird's eye view, then we'll go to the source.
Yeah.
I like that.
Maybe it can tell us where to look.
Yeah. Like starting off with a white paper.
Yeah. Well, this is getting long, but it's really interesting. I think like serverless itself it's like everything else.
Mm-hmm.
It's trade-offs. It's
100%.
Which architecture is right for your application at your point in time, given what you have, what knowledge you have, what you're capable of doing, right?
Yeah, maybe that's it. Maybe knowing what the trade-offs are and what's happening to you. If you're cool with it, then it's cool.
Yeah.
And you determine, no, this is not going to work. It's not going to work.
But this is really bad content, Richard. Don't you understand? We're supposed to come on here and take a side, serverless or no serverless or monolith applications only.
Well, yeah.
No, I think that's the advantage is, you come here, you get the nuanced answer.
Yeah, definitely. I'd be interested in what people think if someone has.
Same.
100%. You know, I can be off track. I'm okay with being off track.
Yeah, are we missing something? Is this actually a situation where serverless is 100% always the answer or 100% never the answer? Like, what are there things we didn't cover that you guys want to know more about? Like, definitely, leave a comment, or even better, go to thereactshow.com, send me an email or a message. You can message us right on there and we can write back or respond on the show. Absolutely would love to hear from you. At least I would. I don't know if Richard probably does. Richard's like, no, I don't want to deal with it.
I'm putting you on the spot, Thomas. I'm talking about some giveaways at some point. What's going on there?
Yeah, so we're gonna give Richard away. So if you want an hour of Richard's time, is that what you're talking about?
Yeah.
Yeah. Well, yeah. Well, that could be interesting. I want an hour of Richard's time.
Nice.
All right. Well, I think that was a lot of fun.
Definitely.
And I learned more about serverless, at least.
Me too. 100%.
Yeah. So hopefully you all have enjoyed this. And like always, thank you so much for joining us. And yes, we would love to hear from you.
Yeah.
If you have any questions.
Any comment?
Yeah. Or like if you've run into issues, one situation or the other, if you've learned things, we'd love to hear and share it with everyone else. Or if you're struggling with this, like if you're trying to figure out what to do in your situation, we'd love to hear from you as well.
Or other discussion topics would be great.
Yeah. Richard, has a lot of ideas, but we'll take a few extras even.
For sure.
Well, anyways, yeah, thank you so much for joining us. I've had a great time and I had a great time here with you today, Richard. But I'm tired and it's time for lunch, and these lights are bright, and so yeah, I hope you all enjoyed this as well, and thank you for joining us, and hope you have a great rest of your day.
Thank you.
See you later.
Bye.
Bye.